In this video, I want to show you a couple of tricks that you will use probably when you're working on project 1. The first thing I want to show is how to build up a data frame. So what I'm doing here is I'm creating a data frame called QT_vals. So this creates a data frame with two columns, the column df and the column critical. This code, by the way, is taken from the write-up of the first lecture. So if I now try to evaluate QT_vals, this is what I get. I get a data frame that has no rows. Now, of course, I can now add rows to it using the function rbind. So if I use rbind, and here I have the Qt values here, and now what I can do is I can add another row to it. Let's say that I want to add the row 1, 2. So C12, that's of course just the vector 1, 2. If I run it, I get the vector 1, 2. And I can add it as another row to Qt values. So the value of this expression is going to be the empty data frame plus the row 1, 2. Now, of course, this is just the value of the expression. If I want to keep this value, I need to assign it back to Qt values, like so. If I run this line, Qt values will change. Qt values is now going to be 1, 2. If I run this line again, what will happen is it'll take the current value of Qt values and again bind the row 1, 2 to it, which means that Qt values will become a data frame with 2 rows, each of which is 1, 2. Let me make something like this. So I'll add the row 1, 2 twice, and then I'll add the row 2, 3 once. And now I'll run the entire thing, like so. QT_vals is now going to be 1, 2, and then 1, 2, and then 2, 3. Now, here's what I did in the write-up for the first lecture. I didn't just bind one row and then another row and then another row. What I did was actually do it in a loop, in a sequence. So here's what I did. Let me copy that. I said my Qt values is going to be a data frame, and here's what I'm going to do. I'm going to say repeat this line for df being 5, and then df being 10, and then df being 20, and every time build up this row is going to be 5 and then this value, and then it's going to be 10 and then this value, and so on. And every time add this row to the end. So let's run those lines and let's check what QT_vals is. So what I did was I evaluated Qt for df equals 5, and then I evaluated Qt for df equals 10, and every time I binded the row to the data frame. You can use this pattern in order to build up all sorts of data frames, the kinds that you would build up when you're building up simulated data. One thing that you would notice is that if I do it this way and not the way I do it in the project handout, the names of the columns change. So that's a little bit unfortunate. I can of course change the names of the columns back by going call names Qt values, and then if I want them to be df and critical, then this is how I do it. I enclose the names in quotes, and I build up a vector that consists of the names, and then I assign it to the column names of QT_vals. If I run this, what you'll see is that I'll get the data frame with the names that I wanted. At this point, one thing I could do, just for fun, this is not really statistically meaningful, is to say, let's build up a linear model where we try to predict the critical value from the df, and the data is going to be qt vals. I get to do this. I built up my data frame, so here it is. In fact, I can have the summary, which would be slightly nicer. This is what we get. We have the df, we have everything. Now, the reason I want to show it to you is because let's say that I want to extract some information from this, and I want to do this automatically rather than by looking at the text. Here's how I would go about it. I would say, okay, so this is the summary, but that's just what gets printed. What I want to do is I want to say, okay, so let's assign the summary to this variable a. And this is what I do when I'm just writing my R code. I won't do it at the end. So now I have this variable a, which contains the summary. So I can say a, and then of course I'll just get the output. But the nice thing is that if I go here, I can actually see that a contains all of this information. So for example, here you see that a contains the coefficients. Here you see that a contains the df. Let's look at that in more detail. So in order to access the df in a, I'll go $df. Here's what I get. So what I get is the degrees of freedom. So for example, here is the 5. Let me get, for example, the r squared. So I can say a r squared, and here it is. So the nice thing here is that now I get to say, okay, so this is a r squared, which means that I also get to say summary $r squared. That's the same thing because this was a. So now that's gonna be like that, and now I can copy this entire thing, and now I get to have this r squared for any kind of scenario if I rerun the entire thing. So let me, for example, remove the 1000 and remove the 320 and try to see what the r squared is going to be in this case. Here's how I can do it. This is the new r squared. If I remove this guy, the r squared is going to change again, and you'll notice that this is the only thing that I'm computing. So I can use this value. For example, I can store it if I am running a simulation and this entire thing is being repeated multiple times.